Quality over quantity. Merit IQ respects your time with precise content. Your dream is our mission. Let's start.
Let's start with the first question. Which of the following launch vehicles successfully deployed both the Chandrayaan-1 and Mangalyaan Mars Orbiter mission into space? A. GSLV Mk2, B. LV-M3, C. PSLV, D. SSLV. Here is a hint. Think of ISRO's most trusted four-stage workhorse rocket. The correct answer is C. PSLV. GSLV and LV-M3 are heavy lifters used later, while SSLV is a new low-cost vehicle designed much after Mangalyaan. PSLV had its first successful flight in 1994 and is known as ISRO's reliable workhorse rocket. It is a four-stage vehicle alternating between solid and liquid propulsion stages. It successfully launched Chandrayaan-1 in 2008. It successfully launched the Mars Orbiter mission in 2013. Here is a memory trick. PSLV proved success in launching venues, Moon, Mars. Revision takeaway: PSLV is the alternate solid-liquid four-stage workhorse that launched early Moon and Mars missions. Next question. What is the payload capacity of the Polar Satellite Launch Vehicle (PSLV) to Sun-Synchronous Polar Orbits (SSPO)? A. 500 kg, B. 1750 kg, C. 2500 kg, D. 4000 kg. Here is a hint. It is considered a medium lift vehicle, placing it between small and heavy lifters. The correct answer is B. 1750 kg. 500 kg is for SSLV, 2500 kg is for GSLV Mk2, and 4000 kg is for LV-M3 to GTO. PSLV payload capacity is 1750 kg to Sun-Synchronous Polar Orbits. It can also carry 1425 kg to Sub-Geosynchronous Transfer Orbit. The core objective is delivering Earth observation and remote sensing satellites. PSLV stands for Polar Satellite Launch Vehicle. Here is a memory trick. PS-1750. Polar satellite lifts about 1.7 tons to orbit. Revision takeaway: PSLV is designed for 1750 kg payloads targeting Sun-synchronous polar orbits. Next question. What is the cryogenic engine powering the Geosynchronous Satellite Launch Vehicle GSLV Mk2? A. CE-20, B. Vikas engine, C. CE-7.5, D. SCE-200. Here is a hint. It is a fully indigenous upper stage engine featuring a 7.5 designation. The correct answer is C. CE-7.5. CE-20 is used in the heavier LV-M3, while GSLV-1 relied on procured Russian stages. GSLV Mk2 uses the fully indigenous CE-7.5 cryogenic engine. It completed its first successful flight with this stage in 2014. It is designed to deliver heavy communication satellites to geosynchronous transfer orbit. Payload capacity to GTO is 2500 kg. Here is a memory trick. GSLV-2 uses 7.2, actually 7.5, think of a 7.5 magnitude earthquake of power. Revision takeaway: GSLV Mk2 is equipped with the indigenous cryogenic upper stage. Let's look at another one. What is the structural configuration of the GSLV Mk2 launch vehicle? A. Two-stage solid propulsion vehicle, B. Three-stage vehicle with solid core and cryogenic upper stage, C. Four-stage alternating solid and liquid vehicle, D. Single-stage fully reusable vehicle. Here is a hint. It features three distinct sections including strap-ons and a very cold final section. The correct answer is B. Three-stage vehicle with solid core and cryogenic upper stage. Four-stage alternating is PSLV, single-stage reusable doesn't match operational rockets. GSLV Mk2 is a three-stage launch vehicle. The first stage is a solid core accompanied by liquid strap-ons. The third stage is the indigenous cryogenic upper stage. It is engineered to carry 5,000 kilograms to low Earth orbit. Here is a memory trick. GSLV 3 stages: solid start, liquid hug, cryo finish. Revision takeaway: GSLV Mk2 is a 3-stage rocket terminating with an indigenous cryogenic engine. Here is the next question. Which launch vehicle is officially designated to execute the Gaganyaan human spaceflight mission? A. PSLV XL. B. GSLV Mk2. C. LVM3. D. SSLV. Here is a hint. This is ISRO's heaviest launch vehicle, formerly known as GSLV Mk3. The correct answer is C. LVM3. PSLV and SSLV lack the capacity for human spaceflight, and LVM3 displaced GSLV Mk2 for deep space and crewed tasks. LVM3 Launch Vehicle Mark III is the chosen rocket for Gaganyaan. It features 2 solid strap-on boosters, a core liquid stage, and a CE-20 cryogenic upper stage. It was successfully utilized for both Chandrayaan-2 and Chandrayaan-3 missions. Its payload limit is 4,000 kilograms to GTO and 8,000 kilograms to LEO. Here is a memory trick. LVM-3 Large Vehicle Manned 3 for India's first 3-person crew. Revision takeaway: LVM-3 is ISRO's heavy lift rocket capable of carrying human crews via the Gaganyaan mission. Let's continue. What engine type serves as the cryogenic upper stage for the launch vehicle Mark III, LVM-3? A. CE 7.5. B. CE 20. C. VTM. D. HEX1. Here is a hint. Think of a perfectly round number indicating a larger capacity than its predecessor. The correct answer is B. CE 20. CE 7.5 belongs to GSLV Mk2, and VTM is the terminal module for the much smaller SSLV. Peace, the CE-20 is the indigenous cryogenic engine designed specifically for LVM-3. It powers the final stage of India's heaviest rocket. LVM-3 uses this stage to push large payloads like Chandrayaan modules into required orbits. The first orbital flight of LVM-3 took place in 2017. Here is a memory trick. LVM-3 uses CE-20. It is larger than the 7.5 engine for larger payloads. Revision takeaway: LVM-3 relies on the powerful CE-20 cryogenic upper stage for final orbit insertion. Let's continue. What primary feature distinguishes the Small Satellite Launch Vehicle SSLV from other operational ISRO rockets? A. It relies exclusively on liquid fuels for all stages. B. It requires intricate launch pads and weeks of assembly. C. It is almost entirely solid-fueled and designed for rapid turnaround. D. It is fully reusable and lands autonomously. Here is a hint. It is built for low-cost, on-demand quick launches in under a week. The correct answer is C. It is almost entirely solid-fueled and designed for rapid turnaround. Reusable is RLV-TD, while PSLV-GSLV require extensive preparation time compared to this quick assembly vehicle. SSLV targets low-cost, on-demand commercial access for small payloads. It requires minimal launch infrastructure and can be assembled in less than a week. The first 3 stages are solid-fueled. It employs a liquid propulsion-based velocity trimming module as its terminal stage. Here is a memory trick. SSLV Solid, Swift and Light Vehicle. Revision takeaway: SSLV offers rapid, low-cost satellite deployment using an almost fully solid propulsion system. Next question. What is the maximum payload capacity of the Small Satellite Launch Vehicle SSLV to Low Earth Orbit LEO? A. 500 kg, B. 1000 kg, C. 1500 kg, D. 2000 kg. Here is a hint. This rocket is appropriately named small and lifts half a metric ton. The correct answer is A. 500 kg. PSLV handles around 1700 kgs, so SSLV must be significantly lower, directly fitting the 500 kg mark. Peace. SSLV can deliver exactly 500 kg to a 500 km low Earth orbit. Its first successful flight was recorded in 2023. It uses a velocity trimming module (VTM) for final orbit corrections. It is aimed at the booming commercial small satellite market. Here is a memory trick. SSLV 555, 500 kg to 500 km orbit. Revision takeaway? The SSLV is designed to propel payloads up to 500 kg into low Earth orbit.
Coming to the next one, what was the primary scientific focus of the Reusable Launch Vehicle Technology Demonstrator (RLV-TD) missions? A. To carry heavy communication satellites to GTO permanently. B. To test a liquid propulsion-only system. C. To validate suborbital hypersonic flight, autonomous landing and reusability. D. To achieve an immediate manned landing on the moon. Here is a hint. This vehicle resembles an airplane and is strictly in experimental testing phases. The correct answer is C. To validate suborbital hypersonic flight, autonomous landing and reusability. It is a demonstrator, meaning it isn't an operational rocket yet, ruling out heavy GTO and lunar flights. RLV-TD is an experimental vehicle, not an operational orbital launch system. It focuses on hypersonic flight, autonomous landing, and air-breathing propulsion. Missions have included HEX in 2016 and LEX in 2023-24. It represents ISRO's step towards drastically reducing the cost of space access. Here is a memory trick. RLV-TD Return Land Vehicle Testing Demonstrations. Revision takeaway. RLV-TD is a two-stage to orbit concept currently restricted to suborbital and atmospheric testing. Let's look at another one. Which vital discovery is attributed to the Moon Impact Probe aboard Chandrayaan-1? A. Presence of microbial life on the Moon. B. High concentrations of liquid methane. C. Presence of water molecules on the lunar surface. D. Functioning active volcanoes on the dark side. Here is a hint. The mission conclusively confirmed the existence of a life-sustaining molecule in space. The correct answer is C. Presence of water molecules on the lunar surface. Methane is relevant to Mars, Mangalyaan, while life and active volcanoes are entirely false for the Moon. Chandrayaan-1 was launched on October 22, 2008. It carried a hard impactor known as the Moon Impact Probe. It never deployed a soft landing rover. The MIP conclusively confirmed the presence of water molecules on the lunar surface. Here is a memory trick. Chandrayaan-1 found Water-1 on the Moon. Revision takeaway. Chandrayaan-1's Moon Impact Probe famously confirmed water molecules on the Moon. Here is the next question. How many total payloads were carried by the Chandrayaan-1 mission? A. 5 payloads. B. 7 payloads. C. 11 payloads. D. 14 payloads. Here is a hint. The mission was an international collaborative effort carrying several foreign instruments alongside Indian ones. The correct answer is C. 11 payloads. Aditya L1 carries 7 payloads. Chandrayaan-1 carried a total of 11, splitting them between Indian and foreign origin. Chandrayaan-1 hosted 11 different payloads. 5 payloads were strictly Indian. 6 payloads were from foreign space agencies, highlighting international cooperation. It mapped the lunar surface topographically and chemically. Here is a memory trick. Chandrayaan-1 had 11, 1 and 1 payloads. Revision takeaway. Chandrayaan-1 carried 11 scientific payloads, including 6 from foreign partners. Let's continue. Despite the soft landing failure of its Vikram lander, which component of Chandrayaan-2 is completely operational today? A. Pragyan rover. B. Moon impact probe. C. Velocity trimming module. D. Lunar orbiter. Here is a hint. This component remains in orbit around the Moon, continuously transmitting high-resolution data back to Earth. The correct answer is D. Lunar orbiter. The rover was lost with Vikram, and MIP belongs to Chandrayaan-1. Chandrayaan-2 was launched on July 22, 2019 via LVM-3. The Vikram lander crashed due to a fine braking anomaly during descent. The orbiter was successfully placed and remains fully functional today. It continues to provide high-resolution topographical and exosphere data. Here is a memory trick. Vikram fell, but the orbiter still overlooks. Revision takeaway. Chandrayaan-2's mission achieved partial success as its orbiter continues to relay high-quality lunar data. Moving on to the next one. What critical component was intentionally omitted from the Chandrayaan-3 mission configuration compared to Chandrayaan-2? A. Lunar rover. B. Lunar lander. C. Lunar orbiter. D. Propulsion module. Here is a hint. Because the previous mission's version of this component was still functioning perfectly, ISRO didn't need to send a new one. The correct answer is C. Lunar orbiter. Chandrayaan-3 focused purely on the soft landing, using a transit propulsion module instead of full scientific orbiter. Chandrayaan-3 consisted of a Vikram lander and Pragyan rover. It did not carry an orbiter payload, saving weight and cost. It utilized a propulsion module strictly for transit to the Moon and communications relay. It successfully landed near the lunar South Pole on August 23, 2023. Here is a memory trick. CH-3 skipped the orbiter because CH-2's orbiter was already working overhead. Revision takeaway. Chandrayaan-3 excluded an orbiter and relied on a propulsion module for transit to lunar orbit. Next question. What name was officially assigned to the landing region of Chandrayaan-3 on the lunar surface? A. Tiranga Point. B. Shiv Shakti Point. C. Jawahar Point. D. Kalam Point. Here is a hint. It is named representing cosmic energy, combining two significant cultural terms. The correct answer is B. Shiv Shakti Point. Jawahar Point is where Chandrayaan-1's impactor struck, while Shiv Shakti is the specific landing spot of Chandrayaan-3. The landing site of Chandrayaan-3 is named Shiv Shakti Point. It landed safely near the lunar South Pole. This made India the first country to achieve a soft landing in this specific rugged region. The landing occurred on August 23, 2023, now celebrated as National Space Day in India. Here is a memory trick. Chandrayaan-3 showed India's Shakti near the South Pole. Revision takeaway. Shiv Shakti Point is the historic landing site of Chandrayaan-3's Vikram lander. Next question. Which launch vehicle was utilized to send the Mars orbiter mission, also known as Mangalyaan, to Mars? A. GSLV Mark III. B. LVM-3. C. PSLV XL. D. GSLV Mark II. Here is a hint. Surprisingly, ISRO used a lighter, highly reliable workhorse vehicle instead of a heavy cryogenic rocket. The correct answer is C. PSLV XL. Heavier GSLVs weren't fully operational or trusted for this profile at the time, leaving the trusted PSLV XL. Mangalyaan was successfully launched using the PSLV XL C-25 rocket. It did not use a GSLV, requiring multiple earthbound maneuvers to build escape velocity. It was launched on November 5, 2013. India became the first nation to reach Martian orbit on its very first attempt. Here is a memory trick. Mangalyaan used the polar rocket PSLV to reach another planet. Revision takeaway. ISRO successfully executed Mangalyaan using the lighter, reliable PSLV launch vehicle.
Let's look at another one. What was a primary payload instrument carried by the Mars orbiter mission Mangalyaan to analyze the Martian atmosphere? A. X-ray polarimeter. B. Methane sensor for Mars, MSM. C. Synthetic aperture radar. D. Moon impact probe. Here is a hint. It was designed to detect a specific gas often associated with biological or geological activity on Earth. The correct answer is B. Methane sensor for Mars. X-ray polarimeter is for XPOSat and SAR belongs to the NISAR mission. Mangalyaan's objective was exploring Martian surface features and atmosphere. The methane sensor for Mars was a key payload for detecting methane gas. It aimed to uncover signs of biological or geological activities. The craft entered Martian orbit on September 24, 2014. Here is a memory trick. Mom searched for methane on Mars. Revision takeaway. Mangalyaan carried the methane sensor to study the Martian atmosphere for organic clues. Here is the next question. Where is the Aditya L1 Solar Observatory physically stationed in space? A. In low Earth orbit, LEO, at 500 kilometers. B. On the surface of the Moon. C. In a halo orbit around Lagrange point 1, L1. D. Orbiting the Sun at the same distance as Mercury. Here is a hint. It is positioned at a gravitationally stable zone about 1.5 million kilometers away from Earth. The correct answer is C. In a halo orbit around Lagrange point 1, L1. It does not land on the Sun or orbit inner planets. It stays in a specific Earth-Sun gravitational pocket. Aditya L1 is stationed in a halo orbit around Lagrange point 1. The L1 point is located 1.5 million kilometers from Earth towards the Sun. This location provides an uninterrupted, eclipse-free view of the Sun. It was launched on September 2, 2023. Here is a memory trick. Aditya, Sun. L1, location 1.5 million kilometers away. Revision takeaway. Aditya L1 operates from the L1 Lagrange point to continuously observe the Sun without eclipses. Let's continue. How many total scientific payloads are integrated into the Aditya L1 mission? A. 3 payloads. B. 5 payloads. C. 7 payloads. D. 11 payloads. Here is a hint. The number is considered lucky and is split between remote sensing and in-situ instruments. The correct answer is C. 7 payloads. 11 payloads match Chandrayaan-1, whereas Aditya L1 is specifically calibrated with 7 observation tools. Peace. Aditya L1 carries a total of 7 specialized payloads. 4 payloads are dedicated to remote sensing of the Sun. 3 payloads are in-situ instruments to measure local environment at L1. It studies the solar atmosphere, chromosphere, and coronal mass ejections. Here is a memory trick. 7 days a week, the Sun shines. Aditya carries 7 payloads. Revision takeaway. The Aditya L1 mission hosts 7 different payloads to study the solar atmosphere and solar winds. Let's continue. Moving on to the next one. What is the designated target destination for the crewed flights of the Gaganyaan mission? A. High Earth orbit. B. Low Earth orbit of 400 kilometers. C. Geostationary transfer orbit. D. The International Space Station. Here is a hint. The mission aims to stay relatively close to Earth in an orbit similar to where space stations typically reside, but entirely independent. The correct answer is B. Low Earth orbit of 400 kilometers. India's first manned flight won't go to deep space or another station, but safely to a 400-kilometer orbit. Gaganyaan aims to demonstrate indigenous human spaceflight capability. The plan is to launch a 3-member crew to a 3-day low Earth orbit, LEO. The exact target altitude is approximately 400 kilometers. They will safely return to land in Indian waters. Here is a memory trick. Gaganyaan stays low, LEO, before India aims high. Revision takeaway. Gaganyaan intends to place astronauts in a 400-kilometer low Earth orbit for a 3-day mission. Next question. What is the name of the half-humanoid robot designed to fly on the preliminary uncrewed Gaganyaan missions? A. Pragyan, B. Vikram, C. Vyomitra, D. Daksh. Here is a hint. The name roughly translates to space friend in Sanskrit. The correct answer is C. Vyomitra. Pragyan is a rover, Vikram is a lander, leaving Vyomitra as the robotic astronaut. Peace. Vyomitra is ISRO's half-humanoid robotic payload. It is designed to simulate human functions during uncrewed test flights for Gaganyaan. Gaganyaan features an orbital module consisting of a crew module and service module. Uncrewed test flights precede the final manned mission slated for 2025-2026. Here is a memory trick. Vyom, space, Mitra, friend. Vyomitra is the astronaut space friend. Revision takeaway. Vyomitra is the humanoid robot testing the Gaganyaan systems prior to human launch.
Coming to the next one. Which Indian satellite is distinctly recognized as the country's first dedicated multi-wavelength space observatory? A. Astrosat, B. Cartosat, C. Resat, D. Exposat. Here is a hint. It studies cosmic sources across X-ray, optical, and ultraviolet bands simultaneously. The correct answer is A. Astrosat. Cartosat and Resat are Earth observation satellites, while Exposat strictly focuses on X-ray polarization. Astrosat was launched on September 28, 2015. It is a multi-wavelength astronomy mission observing X-ray, optical, and UV bands. It is stationed in a 650-kilometer near-equatorial orbit. It focuses on distant celestial objects like black holes and neutron stars. Here is a memory trick. Astrosat, astronomy satellite, looking outwards, not an Earth observer. Revision takeaway. Astrosat serves as ISRO's primary multi-wavelength dedicated astronomical space observatory. Let's look at another one. What specific property of intense cosmic X-ray sources is the Exposat mission designed to investigate? A. Distance from the Milky Way. B. Polarization of X-rays. C. Speed of X-ray emission. D. Volume of X-ray sources. Here is a hint. Focus on the pole in the name of the satellite to find the exact property being measured. The correct answer is B. Polarization of X-rays. Exposat measures polarization indicated in its name, rather than just standard astronomical imagery or distance. Exposat stands for X-ray Polarimeter Satellite. It measures the polarization of X-rays from pulsars and black holes. It is only the world's second dedicated polarimetry mission. It carries two main payloads, POLIX and EXPECT. Here is a memory trick. Exposat, X-ray polarization satellite. Revision takeaway. Exposat represents India's dedicated effort to measure the polarization of complex X-ray sources. Let's look at another one. What type of satellite is the NASA ISRO Synthetic Aperture Radar NISAR? A. Interplanetary Space Probe. B. Early Warning Nuclear Detection Satellite. C. Dual Frequency Earth Observation Satellite. D. Lunar Orbital Mapping Mission. Here is a hint. It is designed to routinely track Earth's ecosystems, ice mass depletion, and natural hazards. The correct answer is C. Dual Frequency Earth Observation Satellite. It is strictly an Earth observation radar mission looking down at our planet, not deep space or nuclear detection. NISAR aims to map the entire globe every 12 days. It is an Earth observation satellite combining NASA's L-band and ISRO's S-band radars.
ISRO is also providing the GSLV launch vehicle. It tracks ecosystems, ice depletion, earthquakes, and tsunamis. Here is a memory trick. NISR sees nature. It observes Earth, not deep space. Revision takeaway. NISR is a joint Earth observation radar mission between NASA and ISRO for monitoring the globe. Let's continue. How many active satellites constitute the core constellation of the Indian Regional Navigation Satellite System, IRNSS, NAVIC? A. 4 satellites. B. 7 satellites. C. 9 satellites. D. 24 satellites. Here is a hint. Think of a lucky number. It's a small but highly effective constellation covering India. The correct answer is B. 7 satellites. GPS uses over 24 satellites globally, but NAVIC is a regional system, needing only 7 to cover its focal area. NAVIC consists of a constellation of 7 active satellites. 3 are stationed in geostationary orbit and 4 are in geosynchronous orbit. It provides highly accurate position information within India. Its coverage extends up to 1,500 kilometers from the national border. Here is a memory trick. 7 NAVIC stars guide the Indian subcontinent safely. Moving on to the next one. Unlike the global positioning system, what type of orbit does NAVIC mostly utilize to maintain constant line of sight over India? A. Low Earth orbit, LEO. B. Medium Earth orbit, MEO. C. Polar Sun Synchronous orbit, SSPO. D. Geostationary and geosynchronous orbits, GEO and GSO. Here is a hint. To stay constantly over a specific region, satellites must match the Earth's rotation speed. The correct answer is D. Geostationary and geosynchronous orbits, GEO, GSO. GPS uses MEO, but NAVIC must stay locked over the Indian region, requiring high-altitude GEO-GSO orbits. NAVIC relies on higher-altitude GEO and GSO satellites. This allows the satellites to maintain a constant line of sight over the Indian subcontinent. In contrast, traditional global systems like GPS operate in medium Earth orbit. NAVIC acts as India's independent alternative to foreign navigation systems. Here is a memory trick. NAVIC stays geo-locked so India never gets lost. Revision takeaway: NAVIC secures constant regional coverage by placing 7 satellites into high-altitude geostationary and geosynchronous orbits. Next question. What is the primary objective of ISRO's proposed Shukrayaan-1 mission? A. Landing a rover in the Martian craters. B. Studying the surface and atmosphere of Venus as an orbiter. C. Penetrating the solar corona. D. Creating a permanent lunar base. Here is a hint. Look at the Sanskrit prefix Shukra to identify the target celestial body. The correct answer is B. Studying the surface and atmosphere of Venus as an orbiter. Shukra means Venus. The mission is strictly an orbiter, not a lander or a solar probe. Shukrayaan-1 is the designated Venus orbiter mission. Its objective is to analyze Venus's atmospheric chemistry, surface topography, and solar wind interactions. It is planned for launch in the late 2020s or early 2030s. It is heavily designated exclusively for orbital, atmospheric, and surface radar study, avoiding landing. Here is a memory trick. Shukra, Venus in Hindi. Shukrayaan goes to Venus. Revision takeaway. Shukrayaan-1 will be ISRO's ambitious interplanetary orbiter mission designed to study Venus. Next question. Which of the following launch vehicles relies upon a velocity trimming module, VTM, as a terminal stage? A. GSLV Mark II. B. PSLV. C. LVM-3. D. SLV. Here is a hint. This module acts as the fine-tuner for ISRO's smallest commercial rocket. The correct answer is D. SLV. LVM-3 and GSLV use cryogenic upper stages,
while SLV uniquely depends on the VTM for final adjustments. The Small Satellite Launch Vehicle SLV uses a Velocity Trimming Module VTM. VTM is a liquid propulsion-based module acting as the final fourth stage. The first three stages of the SLV are entirely solid propulsion. VTM ensures precise final orbit injection for small commercial satellites. Here is a memory trick. Small satellites need trimmed velocities (VTM) to stay in orbit perfectly. Revision takeaway: the SLV caps off its solid fuel stages with a liquid velocity trimming module (VTM) for precise payload positioning. Let's look at another one. What was the primary motive of the reusable launch vehicle RLV LEX missions in 2023 and 2024? A. Testing high-altitude rocket ignition. B. Testing autonomous aerodynamic landing. C. Testing deep space communications. D. Testing lunar orbit insertions. Here is a hint. The acronym LEX stands for Landing Experiment, focusing on bringing the craft safely back to Earth. The correct answer is B. Testing autonomous aerodynamic landing. Since RLV is an aeroplane-like reusable craft, LEX missions strictly demonstrated suborbital landing capabilities. The LEX missions 2023-2024 tested the autonomous landing systems of the RLV-TD. A helicopter dropped the vehicle mid-air and it autonomously navigated back to a runway. This proves technologies required for a fully reusable launch vehicle. Earlier in 2016, the HEX mission validated hypersonic flight features. Here is a memory trick. LEX landing experiment. It had to land itself. Revision takeaway: the RLV-TD LEX missions successfully proved autonomous aerodynamic landing technology for future reusable rockets.
Here is the next question. Which organization is partnering with ISRO to provide the L-band radar for the NISAR satellite mission? A. European Space Agency. B. Roscosmos. C. NASA. D. JAXA. Here is a hint. This mission marks a massive scientific collaboration between India and the United States Primary Space Agency. The correct answer is C. NASA. The name of the mission itself is an acronym reflecting the two collaborating agencies, NASA and ISRO. NISAR stands for NASA-ISRO Synthetic Aperture Radar. NASA is responsible for supplying the L-band radar component. ISRO is supplying the S-band radar and providing the GSLV launch vehicle. This Earth observation project maps global terrain to track natural hazards. Here is a memory trick. N in NISAR stands for NASA. Revision takeaway: NASA provides the crucial L-band radar for the joint NISAR observational satellite mission. Let's continue. During which phase of its journey did the Chandrayaan-2 mission suffer a catastrophic failure? A. Launch phase from the pad. B. Earth orbit raising maneuvers. C. Lunar orbit insertion. D. Fine braking anomaly during descent. Here is a hint. The orbiter was successfully functioning, but an error occurred right before touching the lunar dust. The correct answer is D. Fine braking anomaly during descent. Launch and orbit insertions were perfect. The lander failed right at the last stage of controlled descent. Puzzle: Chandrayaan-2's Vikram lander crashed due to a fine braking anomaly. The error occurred just kilometers above the lunar surface. Despite the crash, the lunar orbiter survived and is fully operational. The mission was otherwise successful in mapping lunar topology. Here is a memory trick. Chandrayaan-2 lost its brakes at the very end of the trip. Revision takeaway: a late fine braking anomaly prevented Chandrayaan-2's Vikram lander from achieving a soft landing. Moving on to the next one. Which of the following payloads was successfully delivered by the PSLV XL C57? A. Aditya L1, B. Chandrayaan-3, C. Mangalyaan, D. Astrosat. Here is a hint. This payload studies the solar atmosphere and was launched in September 2023. The correct answer is A. Aditya L1. Chandrayaan-3 used LVM-3, Mangalyaan used PSLV C25 and Astrosat used C30. Aditya L1 used C57. Aditya L1 was launched via the PSLV XL C57 on September 2, 2023. It is India's first dedicated space observatory to study the Sun. It was placed exactly in a halo orbit around the L1 Lagrange point. It was a major 2023 achievement following Chandrayaan-3. Here is a memory trick. PSLV 57 went to catch the Sun's rays. Revision takeaway. The Aditya L1 Solar Observatory was successfully deployed using the PSLV XL launch vehicle. Next question. What was the primary reason the Mangalyaan mission utilized a Hohmann transfer orbit rather than a direct shot to Mars? A. The PSLV could not achieve escape velocity directly. B. It needed to dodge the asteroid belt. C. To allow time for the solar panels to unroll completely. D. To test experimental liquid fuel. Here is a hint. ISRO used a lighter rocket, which meant they had to build up momentum by circling Earth multiple times. The correct answer is A. The PSLV could not achieve escape velocity directly. Dodging asteroids or waiting for solar panels are not orbital mechanics reasons. The PSLV simply lacked the direct thrust brute power. Puzzle: Mangalyaan used the lighter PSLV rocket instead of a heavier, unready GSLV. Because PSLV lacked direct escape velocity power, ISRO used a Hohmann transfer orbit. The craft performed multiple earthbound maneuvers to gradually build velocity. This economical method was a major factor in the mission's famously low budget. Here is a memory trick. Hohmann transfer slingshot method for smaller rockets to achieve massive speed. Revision takeaway. Mangalyaan relied on a Hohmann transfer orbit to build escape velocity because it used the relatively smaller PSLV.
Coming to the next one, when did the PSLV core vehicle complete its first completely successful flight? A. 1969, B. 1993, C. 1994, D. 2001. Here is a hint. The first developmental flight failed a year prior, but this year saw ISRO establish its most reliable workhorse. The correct answer is C. 1994. 1993 was the developmental flight and 2001 relates to the GSLV Mk2 developmental phase. PSLV's first developmental flight in 1993 was unsuccessful. The first successful flight took place in 1994. Since then, it has launched hundreds of domestic and foreign satellites. It is widely regarded as one of the world's most reliable medium-lift rockets. Here is a memory trick. 1994, the year PSLV started dominating the launch floor. Revision takeaway. The Polar Satellite Launch Vehicle registered its first officially successful launch in 1994. Let's look at another one. Which specific launch vehicle was used to deploy the X-ray polarimeter satellite XPOSat into low Earth orbit? A. PSLV DLC-58, B. LVM-3M4, C. SSLV D2, D. GSLV F12. Here is a hint. It is a specific variation of ISRO's most famous four-stage rocket. The correct answer is A. PSLV DLC-58. LVM-3M4 was for Chandrayaan-3 and SSLV is mainly for small commercial payloads, leaving PSLV C-58.
PSLV C-58 launched the ExpoSat. The launch took place effectively on January 1, 2024. It deployed the satellite into a 650-kilometer low Earth orbit. It carries the POLAX and EXPECT payloads to study black hole emissions. Here is a memory trick. C-58 brought celestial X-ray science in 24. Revision takeaway. ISRO successfully positioned the ExpoSat using the PSLV-DL C-58 mission. Here is the next question. Which Indian space mission primarily involves studying the interactions of solar wind on an alien planetary atmosphere? A. Chandrayaan-3, B. Shukrayaan-1, C. ExpoSat, D. Mangalyaan. Here is a hint. This is a proposed future mission focusing on the second planet from the Sun. The correct answer is B. Shukrayaan-1. ExpoSat studies X-rays, Chandrayaan loves the Moon. Shukrayaan focuses on Venus and its atmospheric reaction to solar wind. Shukrayaan-1 is a proposed ISRO orbiter targeting Venus. One of its key scientific goals is analyzing planetary atmospheric interaction with solar wind. It will also study surface topography via advanced radar. The launch window is expected in the late 2020s or early 2030s. Here is a memory trick. Shukra's thick atmosphere battles the Sun's winds. Revision takeaway. Shukrayaan-1 will analyze the atmosphere of Venus, particularly how it interacts with solar winds. Let's continue. What technological hurdle resulted in the GSLV M1 relying heavily on Russian-procured parts? A. Lack of solid fuel formulations. B. Inability to manufacture liquid strap-ons. C. The complexity of developing an indigenous cryogenic engine. D. Lack of proper launchpad infrastructure. Here is a hint. The third and final stage requires handling liquid hydrogen and oxygen at incredibly low temperatures. The correct answer is C. The complexity of developing an indigenous cryogenic engine. ISRO already mastered solid and standard liquid stages with the PSLV. The cryogenic aspect was the sole roadblock. Developing a cryogenic engine requires handling fuels at extremely low temperatures. Because of this engineering hurdle, early GSLV M1 rockets relied on Russian upper stages. GSLV M2 finally succeeded in 2014 using the indigenous CE 7.5 engine. This made India fully self-reliant in launching heavy geostationary payloads. Here is a memory trick. Cryogenics is so cold, ISRO needed time to bring the heat, develop it locally. Moving on to the next one. Which mission officially made India the first country to soft land near the lunar South Pole? A. Chandrayaan-1, B. Chandrayaan-2, C. Chandrayaan-3, D. Gaganyaan. Here is a hint. This mission famously succeeded where its direct predecessor had crashed just years earlier. The correct answer is C. Chandrayaan-3. Chandrayaan-1 only impacted a probe. Chandrayaan-2 crashed its lander, making Chandrayaan-3 the historic victor. Chandrayaan-3 successfully soft-landed near the lunar South Pole on August 23, 2023. No other nation had safely landed equipment in that rugged polar territory before. The lander, Vikram, deployed the Pragyan rover to analyze the lunar soil chemically. It firmly established ISRO as a global leader in interplanetary landings. Here is a memory trick. Number 3 holds the trophy for surviving the rugged South Pole. Revision takeaway. Chandrayaan-3 achieved historic success by becoming the first mission globally to soft land near the lunar South Pole. Next question. What are the primary instruments actively measuring X-ray polarization on the ExpoSat? A. Vikram and Pragyan, B. Polix and EXPECT, C. Vyomitra and Crew Module, D. MSM and VTM. Here is a hint. One instrument focuses specifically on pole, that is polarization, while the other handles X-ray spectroscopy. The correct answer is B. Polix and EXPECT. Vikram Pragyan are lunar. Vyomitra is a humanoid, leaving the highly specialized X-ray tools. The XPOSAT Observatory carries two core tools for its mission. POLIX, polarimeter instrument in X-rays, measures polarization degree and angle. XSPECT, X-ray spectroscopy and timing, provides spectroscopic information. Both were successfully deployed in low Earth orbit in January 2024. Here is a memory trick. POLIX checks poles, XSPECT inspects the X-rays. Revision takeaway. XPOSAT utilizes the POLIX and XSPECT instruments to deeply study extreme celestial X-ray emissions. Coming to the next one. Which of the following describes the core objective of the Indian Regional Navigation Satellite System, NAVIC? A. Establish human habitation modules in orbit. B. Track deep space radio bursts from active galaxies. C. Provide highly accurate position information services largely within India. D. Land rovers on near-Earth asteroids. Here is a hint. It serves as an indigenous regional alternative to the global GPS network. The correct answer is C. Provide highly accurate position information services largely within India. It is a navigation satellite network, inherently ruling out deep space trackers or human habitats. NAVIC acts as a regional satellite navigation system. It targets civilian and strategic positional accuracy. It operates within India and an external radius of up to 1,500 kilometers. Operationalized in 2018, it frees India from dependence on foreign global navigation. Here is a memory trick. NAVIC navigates India constantly. Revision takeaway. NAVIC's core purpose is supplying independent and highly accurate navigational coverage across the Indian region. And finally, let's wrap up with our last question. How does the reusable launch vehicle RLV-TD differ fundamentally from the PSLV? A. It is designed to burn up in the atmosphere. B. It acts strictly as an orbital satellite. C. It evaluates technologies for a system that flies back instead of being discarded. D. It relies only on solid propulsion boosters. Here is a hint. Its acronym explicitly features the word reusable. The correct answer is C. It evaluates technologies for a system that flies back instead of being discarded. PSLV stages fall into the ocean or burn up, whereas RLV is shaped like a plane to land back safely. Plumping traditional vehicles like PSLV discard stages during ascent. The RLV-TD validates technologies for autonomous re-entry and landing on a runway. It aims to drastically cut the cost of launch payloads. It utilizes a two-stage-to-orbit system with air-breathing propulsion. Here is a memory trick. RLV comes back home instead of becoming space trash. Revision takeaway. Unlike expendable rockets, the RLV-TD tests plane-like reusable technology for cost-effective space access.
Thank you for your time. If this helped you, hit subscribe to keep the logical content coming. Your success is our mission. Any doubts, ask below and I'll answer. Thank you. This is Merit IQ signing off.